Let's first understand what is cross-validation. Cross-validation is a method of estimating the expected prediction error. So you want to know that when you implement your model, what is going to be the error rate. So what is important here is you want to know the error rate once you implement your model to solve a problem, or you implement your model in the production setup. Cross-validation is important from that point of view because it gives you an approximate value of the error rate. Okay. Now, once you are ready with your model, with the final model, all you need to know is that what is going to be the error rate once the model gets implemented. If the error rate is low, then you have built a good model. If the error rate is quite high, then you haven't been able to build a good model. Okay, so cross validation is one method in which you will be able to know the performance of your model even before if you have implemented it. Okay, it helps you selecting the best fit model. So when you build model, you probably have several models in place, models with different methodologies, different algorithms. Whether you are building a regression model or a classification model, you will have several options to choose from. So how do you select the best one? Not just the algo or not just the model methodology, it's also the data, the features that you are selecting. You will have plenty of models in place while selecting the best one out of the options that you have with. The third important thing for which cross validation is very important is it ensures that your model is not overfit. That means it gives you the confidence that the data that you have used to build the model, and by using that data, the performance of your model in that particular data is same as the performance, or at least similar to what the performance you would be getting in the new data, or a data that hasn't been seen yet, because ultimately your model will be implemented to predict values in new data, completely new data, or data that is going to be realized in future. So to ensure that the model is not overfit, cross validation is done. So what are the types of cross validation that you can actually perform on your model? There are basically four types of cross validation that you can actually perform. One is the holdout method, the second one is the KFold cross validation, then third one is the leave one out cross validation, and the last one is the bootstrap method. So we will understand these four types of cross validation one after the other. Let's start with what